All right, for this problem, we've got negative cosine theta equal to sine of 2 theta minus 3 cosine theta. And again, we're asked to solve for theta between 0 and 2 pi. All right, so the first thing we're going to notice here is that we've got a 2 theta, a sine of 2 theta. So we're going to need to use one of our double angle identities. So sine of 2 theta, let's go ahead and replace that. Cosine theta is equal to, sine of 2 theta is equal to 2 sine theta cosine theta. So we've just replaced that sine 2 theta with this, and then we've got minus 3 cosine theta. All right, now we've got a sine and a cosine. That's okay because we can see that this is we can factor out a cosine. But since we're factoring, we're going to need to get everything onto one side of the equation, leave the other side equal to 0. So let's add cosine theta to both sides. And that's going to give us 0 is equal to 2 sine theta cosine theta minus 2 cosine of theta. Now let's factor out that cosine. So we get 0 is equal to cosine theta times 2 sine theta minus 2. We could have factored out a 2 cosine theta, but it'll work out the same either way. Now we've got two factors equal to 0. We can set each of the factors equal to 0 separately. So cosine theta is equal to 0, or 2 sine theta minus 2 is equal to 0. Here, if we subtract 2 from both sides, or add 2 to both sides, and then divide by 2, we're going to get that sine theta is equal to 1. So we're looking for angles where the cosine is equal to 0 or the sine of that angle is equal to 1. So we're going to look on our unit circle. We're going to see that cosine is equal to 0 at pi over 2 and at 3 pi over 2. And then sine is equal to 1 also at pi over 2. So we're only going to get two answers here. They're going to be pi over 2 and 3 pi over 2.